Alright, let's solve this nice exponential equation. Absolutely no calculators allowed. Do you notice any pattern here? Let's rewrite the equation. The goal here is eventually give us something that's easier to work with. So do you see the pattern now? That's right. We have powers of 3 here. 3 to the first is 3, 3 squared is 9, 3 cubed is 27. Now let's rewrite this one more time using the power of a power rule. And then we'll have something we can work with. Check this out. Okay, so we swapped those exponents, the x's and the numbers, right? All right, so here's our trick. Let's make a t substitution. What should we let it equal? Let's let it t equal 3 to the x. Therefore, our new equation in t becomes t plus t squared plus t cubed all equals, did you see how we subbed in there? It's all equal to 8, not 17, oops, 8, 19. Okay, so now let's rewrite it just one more time. So the polynomial is in order of descending degree. Because we will need that in order to use our next trick that's coming soon. Alright, but first, before we do that, let's add the digits of the number 819 together. And we get 8 plus 1 plus 9 equals 18, which is also equal to 9 times 2. But why? Well, if the digits of a number add up to a multiple of 9, then that number is divisible by 9. Okay. I promised no calculator, and I intend to keep that promise. So we're going to do a long division here to get our quotient. Alright, and our final quotient is 91. So that means we can start factoring the number 819. But why am I doing that? If you think you can guess why, drop your guess in the comments before I reveal it later in the video. So, to break down 91, I'm doing my no calculator multiplication here, and we get 7 times 13 is 91. So that means the final factorization of 819 is 9 times 7 times 13. So why did I do all this? Did you guess? Well, the rational roots theorem says that possible roots or solutions to this equation are any numerator divided by denominator combination of p, which are all the factors of the constant term in this equation, which is 819, and divide that by q, which are the factors of the leading coefficient, which in this case is just 1. So there's a imaginary 1 on that t cubed, right? So then we have positive and negative of each, and then all the combinations of those, what quotients do those give us? What are the possibilities? Those are the possible roots. Fun fact, that's why we move t cubed to the front. In this case, all coefficients are 1, but that's obviously not always the case. Okay, now we need to decide which root to try first. So real quick, let's approximate the value of the equation if t were equal to 9. We could do this by substituting, as I've done here, to get 9 cubed, which is also 9 times 81. No calculators again, and we get a product of 729. That's pretty close to 819, right? So it seems like 9 is a pretty good approximation, or a pretty good choice rather, to try to see if it's a root of this equation. So we just plug in. We get 9 cubed plus 9 squared plus 9. And if we get a true statement of equality, then we have found a root of this equation in t. So 9 cubed plus 9 squared plus 9 equals 819. Well, we already computed 9 cubed. That was 729. And we know 9 squared is 81. Plus 9. No calculators, but I'm able to eyeball this here, so I'm going to do that. 810 plus 9. Does that equal 819? It certainly does. So now we know that one of the roots of this equation in t is t equal 9. So now what? Well, I want to see if our equation has any other roots. So let's make a little room here for some more math. And we know that if t is a root of this equation, then one of the factorizations of this is t minus 9. And this is because the zero product property, right? If we plug in 9, we get 0 times something, but it doesn't matter what that something is, we're going to get 0, right? So we know that's a solution to this equation t. But how do I find if there are any other roots of this equation? Well, I'm so glad I warmed up my long division earlier, because I'm about to do an even cooler long division right now. Check this out. So all I have to do is divide one factor, the t minus 9 factor into the original equation, expression on the left-hand side rather, of the equation, and the quotient will give me the other factor, the remaining factor, mystery factor that we have up top. Because multiplication and division are opposites, right? Okay, so let's enjoy this very interesting polynomial long division here and see what we get. So we chose t squared to start, right? Because t squared times t gives us t cubed. To cancel that part out. And we keep going using the same pattern until we can take this to completion and get that final factor. Remember, we subtract here, so when you have a minus of a minus, that becomes a plus, right? So for example, a positive t minus a minus 90t gives us a positive 91t, right? Okay. All right. We need to multiply by 91 to cancel out that final 91t. Same thing with the 9 times the 91. And we have 0 left over, no remainder, so that means our other factor is our quotient here, t squared plus 10t plus 91. Is that cool or what? All right, now we know what our factorization is. what do we notice about the second factor here? Well, it has a square as the leading term, right? So you guessed it, it's a quadratic. Now all we need to do is check the discriminant of the quadratic formula to see if there's another root hiding in there. So the discriminant, or the part that's under the square root in the quadratic formula, is b squared minus 4ac. b is 1 in this case, times 4, and a is 1. And then the 91 part is the c, right? So if we simplify that, 10 squared is 100. 4 times 9 is 360 plus 4 more, 364. 100 minus 364, that gives us a negative, right? So that is less than 0. That means we would have had a negative number on under the square root, and that means there is no real solution to that quadratic part. Okay, so tell me the truth. Did you start singing the quadratic formula song? Let me know in the comments. Alright, so we know that t equals 9 is the only solution to our equation in t, but now what do we do? Well, our original equation is in x, so we need to find what x corresponds to t equal 9. How do we do that? Well, from the zero product rule, we know that t minus 9 equals 0, and we have t minus 9 as our solution. But let's make a little more room here. What else do we know? Well, by our own definition, t is also equal to 3x, right? So all we have to do is just set those two things that t are equal to, right? Because those must also be equal. So we have 3x equals 9. You can probably eyeball what x equals here, but we're going to be thorough because this is algebra. And to undo that, we're going to take log base 3 of both sides. So the log and the exponent cancel out to get x by itself, and log base 3 of 9 is 2, right? Because 3 squared equals 9. So we have our solution in x, but we're at the end of our test, and we still have some time left, so we're going to check our answer right. Good exam practices. So all we have to do is just plug in x to our original equation. So we got 3 squared plus 9 squared plus 27 squared. If that's equal to 819, we got it right. So 3 squared, you know that one, that's 9. 9 squared, you know that one. Times table strong, 81. 27, no calculator allowed. We got to do it. Got to grind through this multiplication here. Keep those skills sharp. All right. So our first row here, we got 49 first, and then we did a 18, and then we have to put a 0 in the ones place. Let's do our second row here. What do we get? 2 times 7 is 14. Remember this? Has it been a while? Been using a calculator? Yeah, I use it a little bit too, but this is a no calculator challenge. All right, and we get 729. That looks familiar, doesn't it? We already kind of added those up before, and we got 819. That means x equals 2 is the correct answer. All right, so if you made it this far, thank you very much for watching. If you enjoyed this or got some value out of it, please consider hitting that like button. It really helps out to help this reach more people. And after you do that, check this video out popping up right now to keep your math journey going, and I will see you over there. Bye.